We've looked at how we can create a box plot from our 5-number summary, so our minimum, our first quartile, our median, our third quartile, and our maximum value. And today we're going to extend that and look at how we can create parallel box plots. So a parallel box plot, as I've written here, is when we have 2 or more box plots that are drawn on the same scale. And the reason why we do this is because it makes it easier to compare the two sets of data. So here we've got some lolly snakes, and down the bottom our scale is the length of that snake in millimeters. And you can see we've got the initial length and then the length when it's been stretched out. And very clearly you get a visual of the comparison between those two data sets. So we can see that the stretched snake has a lot longer length overall than the initial data set. So in this example that we're going to go through together here, we've got the data for the number of goals scored by the Richmond Tigers in the first 10 rounds of the AFL 2017 season. And you should know how to find your 5-number summary from this data and to create a single box plot. But now the added bit that we're working through is that we've got data for the Sydney Swans, looking at how many goals they've scored in the first 10 rounds of that same season. And so what we need to do is construct 2 box plots on the same set of axes like we saw in the previous slide. Before we do that, I'd like you to have a think about what is the range that you will need to include on your axes. So think about, we're looking at both sets of data. So what's the minimum number on there from both sets? What's the maximum number on there? Because that's what you're going to need to include on your axes. So before you turn to the next slide and we go through the solution together, you might like to stop now and have a go at finding your 5-number summary for these data sets, creating your axes, putting your title on, and creating those box plots, and then we can see whether we have done that correctly on the next slide. Okay, so hopefully you've had a go at creating that parallel box plot and you've remembered to include a title up the top, evenly spaced and labelled axes, and labels for each box plot. We're going to go through now how to find the 5-number summary for the Tigers data. Hopefully this is a recap, but if it's not, listen carefully. So first what I've done is I've ordered that data from lowest to highest value, being careful to cross out each data value once I'm done with it. Next I can go ahead and identify this 10 as my minimum and this value of 20 as my maximum. The next data value I'm going to find in my 5-number summary is the median. And I like to do this by working my way from the lowest and the highest value with my fingers and moving one inwards until I find that middle value. You can also apply the formula as well. This is just a technique I like to use. I think it's quicker. So I'm working my way inward, and my median is going to lie between these two values. But when I look at these two values, they're both 11. So usually what I would be doing is, usually what I'd be doing is saying, let's add up this 11 and let's add up this 11 and divide them by 2. But 11 plus 11 divided by 2 is just 11. So I can just say my median's 11. And then looking at, I'll just change my pen color. Looking at this lower half and then looking at the upper half of the data, we can see that there is a distinct midpoint. So this value of 14 is our upper quartile, and this value of 10 is our lower quartile, or our Q1. So that means that my 5-number summary for the Tigers data is 10, 11, 14, and 20, and that's going to help me construct my box plot. And so you can go ahead and take the same approach to find the 5-number summary for the Swans data. Now, this is my axis label, this is my heading, and here are my 2 box plots with their labels for each one. And you can see if I look at this value, it is 10. This value is also, or actually the minimum and the Q1 for the Tigers is the same, so it hasn't moved. So we've got 10, 10, 11, 14, and 20. And then for Swans we can see the minimum's 9, the Q1's 11, the median is 11.5, Q3 is 18, and the maximum is 20. Before we move on and formally compare data, I want us to just notice some things about the box plots we have just created. So what things are similar, or what statistics are similar, and what's different? The first thing that I notice is the Swans data is a lot more spread. So we've got a bigger range from 9 through to 20 versus 10 through to 20 for Tigers. And we've also got a bigger spread in our IQR, or our interquartile range, remembering that that's our Q3 minus our Q1. So that value is 18 minus 11, which is 7 for the Swans, versus 14 minus 10 for the Tigers. The Tigers data is quite spread in its upper quartile. You can see that 14 through to 20, that's only 25% of the data, remembering that 25% lies here, 25% lies here, here, and then in this bottom quarter. Now the bottom quarter of the Tigers is actually all condensed into that score of 10, which is quite interesting. So their minimum is the same as their Q1, which this is real data, so you can see that that can happen in real life. Their medians are about the same. We've got 11.5 versus 11, so they're quite similar. But just thinking about how we can visually compare data before we move on to the next slide. So now we're going to have a look at how we can formally compare data and actually write a paragraph comparing 2 sets. So here we've got test scores for 2 different classes for an algebra topic, and we're going to look at how we can compare them, but also which class has performed better. So when comparing data, especially in parallel box plots, we need to use specific statistical measures and then employ the data from those statistics. So I've created an example for this set. Maybe before you read through the example, you might like to think about which class you think performed better and why. But here's what I've written. So from the parallel box plots, we can see that the median test score for class 1, which is up here, is 80% compared with 75% for class 2. The range, 37%, and the IQR, 13% for class 1, is significantly less than that of class 2, which has a range of 50% and an IQR of 20%. Class 1 is approximately symmetrical, whereas class 2 is positively skewed. A higher median and smaller spread of class 1 indicate that this class had better test scores overall. Now I want you to have a look at the way I've done this in that example. So when you're comparing data, you need to think through, what are the statistics from my box plot whether that be my range, my IQR, my median, they'll be your main ones, that give me information or are good comparison statistics for me to use. I've then stated as well that relevant data to back up what I'm saying. So actually stating the median for both classes to support that comparison. So coming back to today's lesson plan, our purpose was to construct and be able to interpret parallel box plots and to compare them to. So hopefully now you're on your way to be able to find the 5-number summary for data sets and to use that summary to create not just one box plot but now 2 box plots on that same set of axes, so they're parallel, and that you can also compare parallel box plots using statistical measures and data values. So you should have already had a go at that starter activity using this link here. I've just written here that you need to make sure you're checking your answers by clicking that check button at the bottom. And if you are finding it challenging, go back and have another go, or come on the Google Classroom and we can help you out there. The notes and worked examples from the previous slides need to be copied into your bound reference. There's also a worksheet to complete in the class newsfeed, Lesson 7 Parallel Box Plots Consolidation Task. Please make sure you're having a go at that and then correcting your answers using those solutions. And then the last task for today is, after you've completed everything else, is to go to your GAT and complete questions 7, C and D, which is on parallel box plots, and 8A. And a hint for 8A is that the word modal is another word for mode.